Hi everyone, this is a very short tutorial to show you how to import transient DFS2 recharge files into FEFLOW. I will directly start with the workflow, how to do it, for those who are interested only in that. And afterwards, I will give you a little bit more of detailed background information and kind of share with you some limitations and further options. You may know we have this online manual there that's described already a little bit how to do it. There is also a knowledge-based article on the customer care portal for further reference. Here it's also described. I will not go with that in detail because you can read it yourself. We directly jump into the actual tasks. You probably know if you have a MIKE SHE model, the DFS2 output you would find within the SHE result files folder, and it's always called like the model, in this time model, underscore 2DUZ underscore all cells. Now in this case, let's open the file. By default, these transient DFS2 raster grids have 4 outputs. You are basically only interested in that one. You can choose to use only this item in the FEFLOW dialog, but I recommend you always, to be honest, to save this as a clean new file. Ideally, you call it like your run, like n times 2 and like SHE model name, project, whatever. Then you save this DFS2 as it is. And delete the other items, just to be sure. This item type should be always precipitation rate. This is how it's implemented. Yes, save it. Probably have several time steps in there. And always check, this is a little bit dependent on your MIKE SHE settings, if your added geographical information, if you are really using local coordinates. Otherwise, the projection in FEFLOW is problematic. So you really need to use these local coordinates, which are using here meters. If this is not the case, you need to change that here. Okay, this was one example. Now we go into our test dataset. I open here this DFS2, which is a copy of the raw output from my MIKE SHE run, which I showed minutes ago. I always open this DFS2 to be double sure. I check the time steps. Okay, they are all there. My starting date is the 1st of November 1996. I check the item type, precipitation rate, and I check the geographical information, which is local coordinates, and I see here the meters are used. Good. Now, since this import of the DFS2 into FEFLOW, as well as the area weighted projection, can take significant amount of time, you should start this overnight. I normally start this in the evening, and I always make here a small copy of the original DFS2, which I call underscore small. Okay, I created this one already. Let's assume this worked, and I delete all time steps except 3. We see we have a 28 day time stepping, and then I save this one in order to have a small example for the testing of the import to be sure that it works as expected. Now I go into my FEFLOW model. Assuming I have from a previous one already applied some recharge or whatever, you should always make it stationary. Take the first time step, select all values and delete them to be sure that it's clean. Then you can import the DFS2 simply as a map. So this is now supported. I take my small example. Wait a second, I think deletion of the time steps did not yet work. Okay. Guess 13 megabytes. Now I add the DFS2, smaller one. I select the item, I choose cell data. Now in this case, since the output files always from Mike She come along as reverse mean step accumulated, and FEFLOW is considering them with a linear interpolation between two timestamps, you should move this by half of the Mike She output time step backwards. Now in this case, it's the 18th of October. Unfortunately, there's still a bug also in the latest FEFLOW version where there's a small shift, so you need to add here 1 hour to really get the right reference point of time. Now, if it's there, in theory, you can also here visualize it. It will take a little bit of time. Doing that, you can see if there is a spatial overlay. Now, in this case, you can see it here. I would immediately turn it off again because it's very slow with all these cells. Then I do the link to parameter. Check if this is now correct, and this is correct. Because the first time step should be applied after 14 days. Now how it works, you select all time steps that you have here, go to source sync, right click, assign material data to time stages. Then FEFLOW will automatically create the list of time steps that you need. So there can be more, of course. You click OK, you get here a drop down, and then you double click on the first item. And then you see it will align and link each Mike She time step to the time steps in the list of FEFLOW. Here you can choose millimeter per day. Ideally, you have here this user-defined unit. You don't need a topology processing, and instead of value assignment, you choose here this area weighted projection method. You click OK, double click on the link, select all cells, and give it a go. Now in this case, it should work quite fast, but you see even these 16 megabytes take some seconds. To be honest, if you have a normal data set of covering 10 years with a monthly time step, this amount of cells could take a couple of hours. So as I said, start it always ideally in the evening, go to bed, and in the morning it should be ready. Now this looks good. You see already a pattern. My suggestion is also to change here the presets from this one to this one. I invert the values and move here the yellow separator to the middle, because this way I see light blue to dark blue positive recharge values, light yellow to dark red negative values. So this is a nicer color range. You see the minimum and maximum values. Now in this case 10 would be a nice one to have the middle point centered around 0. And then I can step here, build time steps. They do not change now because they are a copy for this test data set. Yeah, this is how it works. And then you press save. Just in case you want to change this one, you again make it stationary and start with the steps from the beginning. Another small trick, just in case you want to exchange the recharge between two files. I need to think it myself. You can also store the time-dependent material data in an external file, and then exchange these ones between two models. If you want to exchange the recharge and it takes a couple of hours, this way can a little bit be faster. It needs some tricks, but it's possible. So this is how the workflow works. I think I can stop with that here. Maybe to share with you some slides here. This is how we developed the workflow initially. So it's possible. Here are the steps described again. This is quite outdated, this presentation, but it contains a little bit more information than the knowledge-based article. That's why I share it here with you. Think about a reasonable output time step. So if the total simulation time is less 1 year, the output time step could be 24 hours. If it's more than 5 years, monthly, just to consider the file size. You cannot define non-equidistant output time steps, but only a consistent time step length. It must be, this is MIKE SHE related stuff, so the MIKE SHE modeler, if you're it yourself or your colleague, need to consider this. Yeah, we normally choose here for monthly output time steps and then 730 hours. That aligns quite good with the use set time stepping in MIKE SHE. This one I told you already. If you have here both, keep the geographical coordinates so that you have here the meters. You can read this one yourself. Yeah, the first time step in MIKE SHE is per default always 0. If you want to have here already values, you should copy the second time step to the first one and save the DFS2. Here are the steps I just described with you. One more thing is quite interesting. When we created this workflow the first time, before it was really implemented into FEFLOW as an import, we created this with a tool. In this case, the showcase, and also the one that I showed you is for the Linux. You see it worked quite fine. And you have here a nice different pattern here for the wet season and for the dry season, not session. And of course, you can inspect within each cell the time series here. So you can really provide here very high resolution in time and space for your MIKE SHE model in terms of the recharge. This one I told you also already. Consider this 1 hour, which is a kind of bug. We hope to solve this one soon. One important thing, it can be if you don't use the phoretic approach in FEFLOW, this can lead to problems if you have high recharge values. You see here some notes, feel free to read them yourself. Yeah, this one is interesting. Currently, the FEFLOW internal DFS2 import function is only enabling the in and outflow on top bottom in millimeter per day. If you want to apply it as sync source, the client has to divide it by the layer thickness of the first saturated layer, because inflow and outflow to top bottom is millimeter per day. Sync source is 1 per second. So you need to divide this by the layer thickness to the one that you want to apply it. Applying it to a certain layer only works with a script that you can request from me. My email is phhu@dhigroup.com. It's a little bit outdated, but you can have the script just in case you want to have it. This is important because via the approach in and outflow to bottom, the water is passing through the unsaturated zone, of course, 2 times, because you calculated in MIKE SHE through the complete unsaturated zone. And if you apply it to the top of the FEFLOW and you have again, let's say 10 meters or more of depth to phoretic surface, you get a time shift. But via the sink and source term, you can squeeze in the water directly into the desired layer, which can lead to instabilities. So this is a little bit problematic if you have a confined layer. Yeah, that's it. If you want to squeeze in the amount of water via sink source, as I said, you can have this script that another colleague, Alex, developed here, but maybe it needs some further work. Otherwise, I recommend you to go for the in and outflow approach, which is the easiest one, where you can use the default import function. The only thing worth mentioning here is there is also a workaround. I will add this later, where you do not need to necessarily take the raw output from MIKE SHE, which is called total recharge to saturated zone. Instead, you can take precipitation minus the evapotranspiration from the soils. Then you get a kind of net infiltration at the top of the MIKE SHE cells, and you calculate the percolation downwards only 1 time, and in FEFLOW, if you apply it, is in and outflow on top bottom. So this is also possible. Thank you very much. Have fun.